Right, welcome to our Network Plus Bootcamp series that's going to be running for the next 6 weeks. I am going to put a slide that is going to cover everything that we're going to be looking at, the dates, the times, for those that want to catch us live. This recording is going to be running on our YouTube channel, and it is also going to be running on our Facebook page. So if you are joining, welcome. I'm just going to take the next 30 seconds to a minute, just making sure that the stream is coming up on our Facebook page, and then I can start our presentation for today. Okay, so it looks like it is showing on our YouTube channel, and I'll have to check the Facebook page after that. But once again, welcome to this series, which is a free Network Plus series. I have been wanting to do this, and I'm going to cover, some of the reasons that basically led me to this particular point. So without taking much of our time, let us look at the slide that I want us to basically focus on today. For those that don't know me, my name is Tinei. I work as a network engineer in Australia, in Perth. And at some point, I was where most of you are at the moment. If you are starting your journey in your career in networking, and you don't know where to start, you don't know what course can take you to where you want to be, becoming a network engineer. So all you know is that, at some point you want to be a network engineer. And I will basically just start this series by just introducing myself, share a little bit information about who I am, what has been my journey, why I've basically decided to go down this particular path and run this particular course, what is the intention, and how best we can utilize each other's time throughout the entire duration of the course. I am going to be running this course mainly more like a classroom, right, where we're going to be interacting. You can see the slide on the screen at the moment. You've got my email address. If you've got any questions, please don't hesitate, send me an email. And this is going to be broadcast live on our YouTube channel, so you can post questions on there, and I'll be able to answer those particular questions. This is going to be a 6-week bootcamp. And the reason why I'm running this bootcamp is that I have been getting a lot of questions from people who wanted me to run a course that could probably help those that are starting their journey in the network industry. So I thought I'm going to run a 6-week, Network Plus bootcamp. It is a trial. We might do more days, but for now, it's going to be Tuesdays and Thursdays, and that's going to be running 9 p.m. AWST, which is Australia Western Standard Time, and Central Africa time, that's about 3 p.m. You can be able to check where your time zone fits in that schedule. I'm also going to put a link to the Facebook page so that you can be able to join that group. I'll be able to provide notifications on that particular page. You don't have to join it. You just have to, if you want updates on, sometimes things shift. I'm a parent with 2 kids, and I might not be able to come in at 9 o'clock, but the intention is 9 o'clock for the next 6 weeks, 9 o'clock Tuesdays and Thursdays. We're going to be running this, and my intent is to run this for a minimum of 2 hours, 3 hours max. But yes, so please participate, ask questions, show your thumbs up, just show me that you are there so that we can be able to interact. And outside of this particular class, feel free to send me emails with any questions. I will answer them in the next lesson and we can be able to cover. So I've gone through the basic housekeeping. So I think I've covered everything that I wanted to cover in that regard. So 2 things about me. Without taking too much of your time, I got into the network industry about 21 years ago. I was fortunate that someone offered to teach me free of charge. And that was my entry point into the industry. So I got a scholarship. We were 10 of us sharing one textbook in not the most best of classes, but I knew what I wanted to become. And just through that one experience, my life got turned around and I am who I am now because of that one experience. So the reason why I'm sharing this story is you might not have many resources and you're thinking to yourself, there is no hope for you in life. But I stand here today as a testimony that one textbook amongst 10 people can work miracles. And I'm one of those miracles that were a result of one textbook. So if I can do it, you can also do it. It's just a matter of time. It takes focus, but you can definitely achieve. And one day you can be the network engineer that you want to be. I grew up in Zimbabwe, in a small town called Tinei. And now I've worked with multinationals and being a network engineer in Australia. I've worked in Perth, I've worked in Sydney, I've worked in Darwin, I've worked at a gas plant. So there's nothing that can stop you from achieving what it is that you want to achieve. The only thing that you need to do is to be able to put your focus into the work and you will be able to accomplish. So that's number 1. Number 2, my goal or my vision, personal vision, is to train at least 1,000 network engineers by 2025. And this is going to be one of the vehicles that will allow me to reach out to you and be able to share the little knowledge that I have experienced in the short time that I've been in the network industry. I'm very passionate and I look forward to this particular journey. So housekeeping is done. So what is going to be covered in this course? The Network Plus is broken into 4 categories. There is the network fundamentals. This will basically introduce us to the whole concept of networking, what is covered in Network Plus, what do networks entail, what's the infrastructure that we're going to encounter, and what are the core fundamentals that are important for us to be able to understand in order for networking to make sense. So you're going to look at things like the OSI, TCP/IP, the different network types, topologies, the infrastructure, cabling, connectors. So that's going to be one section, and that's going to be followed by network implementation, where we then transition to now implementing our networks in our corporate environments. And what does that entail? You then go into network operations. Network operations focuses on how to operate a network. Things like documentation, things like change management, things like network diagrams. What does that involve? That's what is going to be covered in network operations. And then you're going to look at network security, which will then look at how we can protect our network. And then the final encompassing module is network troubleshooting, which is basically going to touch all the 4 touch points. So for those who want to have a skeleton perspective of what it is that you're going to cover, this is what is going to be covered in the particular course. So that's in a nutshell. So without taking much time, let's go to our first slide for today. Now, I am more interested in why things happen than implementation of something. And I'll take a step back to be able to explain this, because for me, if you're going to understand technologies, it is important for you to understand the reason why a particular technology or a particular reference model was basically created. So you're going to find that throughout this course, we're going to anchor around the concept of the what, meaning what is the technology that we're looking at. We're going to look at why. Why do we need it? Why do we need that particular technology? So if it's wireless, why do we need wireless? What problem does it solve? When do we implement, or when do we need wireless? And then how do we implement? So that's going to be the focal point of the 4 questions that we basically try and answer as we basically go through this particular course. And the first topic that we're going to be talking about is the OSI model. I'm sure you've heard about the OSI model at some point being spoken about. What is it? What does it do? What problem does it solve? Why was it even created? And I thought for us to understand this concept that is basically foreign, let's start with something that you and I understand. You and I can basically picture this vision and be able to work with it. Now, for many people, you rent a house. You rent a house after COVID, depending on which country you're in, rentals basically went up because there was a shortage of houses, because for 2 years, no one was constructing anything. So now all of a sudden, there was a problem. Rentals have gone up. People can't afford rentals, or some people were renting because building was expensive. But then when rentals went up, it then made more sense for someone to rather build and pay mortgage rather than continue to rent. So probably you're wondering, what does this whole rental example have anything to do with networking and the OSI model? Now, when you choose to go and build, there are certain steps that you basically take in that process. The first step is you're going to research the house that you want to build. How many bedrooms is it going to have? Is it going to have 4 bedrooms? How many bathrooms? Double door garage. They are the basics that you basically start with. Now, when you have this concept in your mind, you then go and look for the land. Now, where is it that you want to build? Where is it that you want to stay? Are you going to be staying closer to work? Are you going to be staying closer to the train station? So you find the land, right? We're working through a process here, and work with me, and I'm sure we'll get to the point where I want us to get to. So now you have found the land. Now the most important step then happens. You then go and see someone who's known as an architect. And this architect, you tell him your plans. Thank you, Cartoon Man. I'll make a playlist that people will be able to follow. And that's going to happen when I finish this recording. I'll make a playlist, and I'll also update in the description below. Right, so without losing my train of thought, so you've gone to an architect. The architect is going to create a document that is known as a floor plan or a building drawing. And it is this document that forms the direction that everyone who's going to get involved in the construction of the house will reference to that particular document. And what do I mean? The guy who's going to do the site clearance and dig the foundation. They are guided by the dimensions of the floor plan, right? So the floor plan that you get from the architect is the one that's going to decide the dimensions of the people that are going to dig the foundation. So they're going to dig the foundation. And then after the foundation, they're going to put a slab. And when the slab is completed, the next step is something known as framing, where they put the sides of the house, which is the walls. They put the windows. And at some point, that's when plumbers are going to come in to make sure that they lay their pipes in between. Now, the person who manufactures the pipes for your sewage and for your water, and the person who manufactures the electrical cablings that are going to be running in your house, those people are totally separate manufacturers. But they've got one common document that they all reference to, which is your drawing plan or your floor plan. And that is the guiding document that makes everything else happen. So the OSI is a framework. It is a framework that basically was created because there was a problem. In the 1970s, most computers were individually owned by different providers. So a typical case in point for 2022 is, imagine Apple has got their own range of products, and Apple machines cannot talk to Windows computers, right? There was no middle ground. Everyone made their own product, which include their operating system, their network protocols, the network. So Apple machines could only function on an Apple network and nothing else. Windows machines could only function on Windows network and nothing else. And there was no interoperability because everyone was designing their ecosystem in the way that they understood best. So when the OSI was drafted, the framework was trying to say, how do we get different developers who are going to develop or write code for different layers of network connectivity for devices to come up with a standard that then allows Google to make their own browser called Google Chrome, Firefox to make their own browser called Firefox, and yet when you put them on either Windows or a Mac machine, everything works without any additional configuration. So when you look at the OSI, or when you think about the OSI, just understand that the framework was created trying to solve a problem. And they basically looked at the different layers. I'm just going to try and see if I can just take my, take myself out so that we can be able to have a good screen without much of the disturbances. Okay. So when you look at the OSI, I want you to think of a blueprint, right? A blueprint that, okay, a blueprint of how communication takes place in the network. And it is defined in what is known as a top layered approach. So there are many ways of looking at the OSI. You can look at it from top down or bottom up. I tend to prefer looking at it from top down. And I hope that the example of the building of a house starts making sense, because you start with the foundation, you put a slab, from the slab you put the walls, from the walls you put the windows, you put the roof trusses, you put the roof, you put the ceiling, paint, and then everything else functions. So the OSI is a framework, and that basically becomes, our starting point. Now, the first layer that we're going to look at is what is known as the application layer. And the application layer is where we have human interaction in the form of applications that basically talk on the network. So you and I, we open our machine, we open a web browser, might be Edge, Chrome, Firefox, whatever the web browser is. We type our website address, we press enter, and then the information starts flowing through. It's that simple, right? Now we have interacted with the web browser, and that web browser is operating at the application layer. So that is basically the starting point of the flow of the OSI. I feel like I'm not present if you can't see me. So let me just bring my face back somewhere, and it's okay. I need to get this guy coming backwards. That's fine. Okay. Okay, just a second. Okay, cool. I wanted this. I'll bring back the screen. All right, yeah. So I'll bring back that screen, and let me just take us a step backwards. All right, so with time, we'll get this whole setup working as per expectation. All right, so we're looking at the human interaction. So the application layer is the starting point that we all come into, and we interact with the application. And in this case in point, the application we are using is Google Chrome, but the back-end application is HTTP, because that's the hypertext transfer protocol that is used when you're collating web pages. You got things like FTP, which is your file transfer protocol. All these are application layer software protocols. When you type an email, you type it on your email client of choice, and that could be Outlook or whichever email application that you're basically using. So we interact with the OSI at the application layer, which is basically our starting point. Now, I like giving examples because I think examples make learning a whole lot simpler. Now, I want you to picture yourself writing a letter. I know this is something that doesn't happen much in 2022, but back in the day when I grew up, right, we used to write letters. And I'm sure it's funny for you to hear me say that. But yes, at some point we used to write letters. So you write your letter, you take a pen, you take a piece of paper, you write whatever you want to write. Now your interaction on that piece of paper and pen, that's your application layer. Now you can't just send your letter by just folding it and just send it, because number one, it's not protected. Anyone can open it and they can read it. So the normal process is you put your letter in an envelope, and then in that envelope, you then put an address of where it's going and everything else that comes along the lines. So that is something similar. So on the application layer, we've had the human interaction, but the moment you finish writing our letter, it has to go to the presentation layer. So I want you to think of the presentation layer the way you look at an envelope, right? So the presentation layer, the responsibility of that layer is to translate the data in a way that the coding of the computer understands, right? Things like ASCII. So the presentation layer translates, as the name says, present. It presents information from one layer to another. So if it's coming from the bottom end, it will be from the session layer going up. If it's coming from the top, it's taking that and packaging it into an envelope so that the information can flow down the OSI. Now, two things happen at the presentation layer. The first thing is compression, right? This is where it compresses the data. Encryption also happens at the presentation layer because at that particular point, the data is in its raw format. It's not encrypted. And if you were to transmit it as is, anyone could be able to open the data along the way try and see what's going on, and that data will not be secure. Now, imagine you're trying to log into your bank website and you're putting your username and password and your data is not secured. So presentation layer then takes care of the encryption and the decryption. That is followed by the session layer, which handles or maintains sessions between different hosts that are trying to communicate. And I think I'm going to show that much more better in the next slide. So when you think about the OSI layer, have one set of layers on the right, sorry, on the left-hand side, and have another one on the right-hand side. And just picture yourself having communication between the two endpoints. So the session layer is responsible for establishing a session that then allows for data to then basically be transformed. So its key responsibility is basically to open a session, maintain it, and to close it when the communication has happened. Now, these are known as the three top layers of the OSI. The four bottom layers, for me, this is where the action begins. This is where the data starts getting transferred from one endpoint to another. And we come across the transport layer. And for the transport layer, this is where you encounter the protocol known as TCP, which is the Transfer Control Protocol. I'm sure many of us have encountered TCP at some point. We might not have had a full picture of what it does. But in this transport layer, this is where you're going to encounter TCP and UDP, right? These are the two protocols that operate in the transport layer. One of them is known as a connection-oriented protocol, which means that it makes sure that it establishes communication between two endpoints and verifies the communication throughout until the data has basically been transmitted. And the simplest example that I can give you is when you make a call, right? So if I were to call you on your mobile phone, my phone would ring yours and it would wait for you to pick up. When you pick up, then the call has been established, which means that you and I can start talking. And in between you and I talking, the phone is communicating in the background, making sure that our session, right, is continuous. Otherwise, the session would what? Would then drop. And then when we're done, we cut the phone, and then that session is basically closed. So TCP is a connection-oriented protocol, and it requires that communication to happen, and it monitors that communication. And I'm going to talk about something known as a three-way handshake, which we're probably going to be discussing later on. And then UDP on the other end is like you sending a letter, right? When you send a letter, you really don't care much about the letter making it to the destination. When I'm saying you don't care much, I'm not saying you don't want the letter to make it to the destination, but you don't track the letter at each and every point to make sure that the letter makes it to the destination that you're trying to get to. And to be able to illustrate this, let me try and see if I can be able to draw this on the screen. Okay, right. So this is our letter. So this is our envelope. So we write our letter, we take it to the post office, right? We put it in the post box, and that letter goes. At no point do we track our letter. That letter makes it to the destination without us tracking, and that is known as connectionless. And as you can imagine, if we are looking at cost, the cost of sending a letter is basically putting a stamp. Because you're not tracking the letter, there is no price point to it. But then with TCP, because it is handling the whole transaction and it is interested in knowing about the destination, it uses something known as a three-way handshake. And what a three-way handshake is that, so let me see, right. So we've got PC1 that's trying to talk to PC2. Right. Before the communication starts, they send what is known as a SYN message. And what that SYN message is basically trying to say is, I want to talk to you, right? And then it waits for a response known as a SYN ACK, which stands for acknowledgement. So the other PC acknowledges that, okay, I've received your request that you want to talk to me, and I am ready to talk to you. And then that is closed off by sending another ACK. So now you've got a three-way handshake. And it's only at this point that the handshake has been established does communication start on that particular channel. So I have to say this, not cautiously, but I hope you're trying to, you're seeing or getting how TCP then operates. So when that is basically established, then the connection is now running. So we've got a connection. And then these two machines agree the frequency that they're going to be checking on each other. So I will send one packet, I'll send two packets, I'll send three packets. But before I send the fourth one, I will need to get an acknowledgement from PC2 to confirm that he has received the first three packets. Otherwise, I might be sending packets that he's not receiving. And then that in itself then creates a problem. And that process is known as windowing. All right, I'm just going to clear my screen and probably just draw the windowing part in a much clearer way. So PC1 sends one packet, two packets, three packets. So they're using a window size of 3. But before he sends the fourth packet, he needs to get an acknowledgement that is sent from PC2 back to PC1 to acknowledge that I have received your information. And then when he gets the acknowledgement, he then sends packet number 4, number 5, and number 6. And then once again, an acknowledgement gets sent back, and then he sends going this way. So what that guarantees is that the packets that are sent have made it to the destination. And in the event that he does not receive the acknowledgement, then he will resend that particular information back to that particular host in question. So that's the concept of windowing that you're basically going to encounter when we look at TCP/IP. Later on in the course, we're going to go through in detail. Right now, I'm just basically summarizing so that you can have an understanding of how the OSI layer affects the thing that we deal with on a day-to-day basis. So we have looked at the transport layer, and we say TCP and UDP are the two protocols that are involved in the transport layer. And we mentioned the fact that they're connection-oriented and connectionless, and looked at the differences between the two. So after the transport layer has completed its part, it then sends it to the network layer, which is known as the network layer or layer 3. This layer is basically responsible for two things. Number one, the routing of the packet that basically comes through. So what is the best route to get to the destination? That's the first one. And the second one, it is responsible for IP addressing. And I'm sure by now you've heard about IP addresses or you've encountered IP addresses at some point. This is a layer where IP addresses basically function in the OSI. So the OSI layer is not a framework that is void, that just operates without. No, its layers affect us on a day-to-day basis. So whilst you might not go to work and say, I'm going to be interacting with the OSI layer, but when you sit on the browser and you go to a web page, you're basically operating on the application layer. That data has to be presented and it flows down and it gets to the IP addressing. And for me, this is when networks start, when you're dealing with the layer 3 or the IP addressing layer, because devices such as routers operate in this particular space. IP addressing and subnets and all the nice things about IP addressing, IPv4, IPv6, they all operate at the networking layer. The networking layer, also known as layer 3. So you probably hear people interchanging, saying layer 3 or networking layer. They're basically referencing to this particular aspect. So the most important part is deciding the path. So how do routers make that particular decision? So I'm just going to draw. So I've got router number 1, router number 2, router number 3, router number 4. Right. So here, number 4, number 3. So we are trying to get to this network X, and we are coming from network Y. So when a packet comes through, this router has to decide which is the best path to use to get to that particular location. Do I go this way or do I go that way? And depending on the configuration that has been made on that particular router, whether it's a static route, whether it's a dynamic routing protocol, it then makes that particular decision. And we'll then look at how do routers make that decision? What are the methods that the routers use to make that particular decision? And once again, if you're to take a step backwards and ask yourself, how can you relate the technology that you are encountering on a day-to-day basis, and how can you find examples of the things that you deal with daily that can help you understand the technology? The more examples that you can be able to relate to network or IT concepts, the more it is easier for you to understand, what is basically being spoken about. So this whole concept of routing is same thing. When you send your letter and you go to the post office then decides you are sending a letter that's coming from Perth going to Sydney. What is the best path to take it there? Number one, they're going to look at things like cost. Are we going to send it via air? Are we going to send it via road? Are we going to send it via rail? Right. If you're sending a car, maybe flying it might be too expensive. It might not make sense. So you're going to send it via rail. So I want you to start visualizing some of these things relating to what we deal with on a day-to-day basis. All right. So this is a bit covered on my screen, and I'm just going to take myself out a little bit just so that you can see the last two layers. So you've got the data link layer. Now this deals with the translation of the data into something physical, right? So this is where you're taking the data and you're sending it to your network card. And let me clear my screen. I'm sure you've heard about something known as a MAC address. Okay, things did not go as expected. Let's see, just take that backwards. Okay. Okay, all right, it's fine. I think we're back. Okay, things seem to be going back. Let me just try and get back to my slide. All right, this is the slide that I want. Then I need to take this back this way. Okay, fine. Right, so in the data link layer, this is where you find layer 2. It's also known as the L2 layer. You find devices such as switches. They operate in the data link layer. You come across MAC addresses, and I'm sure by now you probably would have encountered a MAC address. If you don't know what a MAC address is, it is basically a unique address that is found on any device that needs to talk on the network. And this is the address that hosts use to be able to reach the other end of the network. Yes, we talk about IP addresses, but beyond IP addresses, beyond IP addresses, you've got the MAC addresses, which is the network interface card, and that basically operates in the data link layer. And then the OSI then gets closed off by looking at the physical layer. And this is where you find the cables, the UTP, Cat5, Cat6, they operate on the physical layer. And this is where data gets converted into electrical signals, ones and zeros, and it gets transmitted as it goes through the network. Sorry. Okay. So if anyone has any questions, please don't hesitate. Just send them on the chat for those that are connected live. And for those that are not live, you can send your questions by email, and I will be able to basically explain. So I'm just going to bring my face back so that you can be able to see me. So the OSI, once again, is a framework. And not every layer is going to fit to every explainable action. But the whole objective of the OSI is for different providers to have a framework that helps them understand how things are going to flow on the network and how they'll basically participate. So what that does is that the guy who makes cables can go and make UTP, Cat5, Cat6, Cat7, whatever category of cable that they're making, knowing that when they take that cable, they're going to plug into or terminate it into an RJ45 connector. And that RJ45 connector is going to connect to your network card. And the two are going to be able to communicate without any issues. And the reason why that is taking place is because there was a standard that was defined and described at some point that everyone else who wanted to participate in this thing called networks was able to then go to that particular document and understood how they could then make the product, the software, the application in a way that it could then talk to the rest of the systems. And one of the simpler examples that I like to give when I'm referring to the OSI is you picturing a car Now, the components that make up a car are not manufactured by the same company. The company that makes the engine is not the company that makes the tires. The tires are made by a different provider. The rims for the car are made by a totally separate provider. But it is because of the standards that these guys use when they're making their particular products that makes a rim made by company X fit into a tire made by company Y, because they had a document that allowed them to interoperate and make products that would be functional across the whole vehicle ecosystem. So they have a common document that then serves as the guiding document that helps them along the way. So the OSI is simply that document in a networking standpoint, where anyone who wanted to participate would then go and have a look at the OSI and then understand that, okay, if I'm going to be writing an application that wants to get web pages, I need to use HTTP or HTTPS. If I'm going to be writing an application that needs to collect files, I'm going to use FTP as a protocol, and then I'm going to write on that basis. And then you've got a guideline. So it is important for you to understand the OSI layer and how it functions, how it operates. It is very key because it's something that you're going to interact with on a day-to-day basis. And you're going to see the need of the OSI layer when you start dealing with troubleshooting, when things are not working as per expectation. You then use the OSI layer to be able to troubleshoot where the root cause of a problem might be. Is it at the application layer? Is it at the network layer? Or is it at the physical layer? And in this course, we're basically going to cover all these things in detail to be able to help you as you go through your own particular journey. So going back to our slides, the OSI layer has been shrunk into something known as the TCP/IP model. And the TCP/IP model has basically been the one that has been adopted of late. And what the TCP/IP model basically did is it combined the top three layers of the OSI and classified them as the application layer. And then the transport remained as the transport. Network was network, but it combined the the data link layer and the physical layer into something known as the network interface. So you're probably going to find the need, you're probably going to find them called by the different names. You find people talking about the TCP/IP model. It's just basically a condensed version or a compressed version for ease and simplicity, because the application layer is basically an abstract that can be combined into one particular layer. Okay. The other thing that I wanted to highlight in this particular slide is the segments, packets, frames, and bits. And this is more for people who want to, write the exam, because this is one of the questions that basically comes in the exam. Them wanting to find out if you understand which of these four operated what layer, right? So segments are in the transport layer. So anything that happens in the transport layer, it is in segments. And then as you flow through to the network layer, you deal in packets, right? So you find packets on layer 3. And then when you go to layer 2, you're dealing with frames. And then when you go to layer 1, you're going to be dealing with ones and zeros, which are your bits or your binary. And then also on transport layer, you're going to be dealing with ports. And this is where you're going to be looking at, the different ports that are available. We're going to look at some of the common ports later on. On the network layer, you're dealing with IP addressing. On the data link layer, you're going to be dealing with the MAC address. And then once again, on the physical layer, you're going to be dealing with ones and zeros, which are your bits. Right. Let me move this one. All right, so I'm just going to take a 30-second breather just to recompose my voice, and we will basically continue. I hope you're finding value. Once again, the format is more of a classroom. I know this is the first lesson. There's not going to be much interaction, but for those that might be joining us now, this class is going to be running for the next 6 weeks. It's going to be running on Tuesdays and Thursdays, 9 p.m. AWST, which is about +8 GMT. If you are in Central African time, that's around about 3 p.m. And I think if you're in the UK, that's about 1 p.m. And depending on where you are in the US, it could be 6 a.m. or somewhere around that time. So you can just identify the particular time zones. You can send any questions to my email address, which is going to be included in the description below. Send any questions. I will try and answer some of them live, and some of them I'll basically carry them onto the next lesson, and we can be able to work through together as we basically go through. All right, so the next aspect is encapsulation. And encapsulation is basically a process where you take, let's see, what do I need? Just a second. Right, encapsulation is basically a process where you wrap data from one source into another, where you wrap data before you transmit it. So we write a letter, we put it in an envelope, we have basically encapsulated. Right, so that letter is now in an envelope. We take the letter to the post office. The post office takes that letter, they put it in a post bag. That is a form of encapsulation. And then from the post box, it's put in a bigger container. And that container is either then put on a truck, put on an aeroplane, put on rail, depending on what format they're going to use to be able to then transport it. So in our OSI layer example, encapsulation is basically the data being wrapped as it flows through the layers of the OSI layer. So in our case, we've got okay, got that. Okay, cool. So we are coming from the top, right? When we get to the session layer, we've got the data, and this data is still pure. But when the data then gets to the transport layer then encapsulates the data and provides its own header. And what this header does is it basically allows the transport layer the ability to be able to then transport that particular packet or segment to a particular destination. And then as it goes from the transport layer onto the network layer is going to encapsulate. So it's going to wrap around this data, and then it's going to apply its own header. And I'm probably going to explain the whole concept of headers in the next slide, because it might not be something that is intuitive for one to be able to then, grasp and understand from the very onset. And this happens all the way up until you get to, the data link layer. So by the time you get to this layer, you've got the layer 2 header, which encapsulates the layer 3 header, the layer 4 header, the data, and then it puts a trailer at the end. And this trailer is basically there to ensure that there are no errors as the frames get transmitted from one source to another. So the encapsulation process starts from top down, and then when you get to the destination, you go up the OSI layer. So once again, you start with the physical, you go to the data link, you go to the network, up to the transport. And what then happens is the process of decapsulation. So the process of decapsulation is now you are unpacking the shell and passing forward the actual data that has been transmitted or intended to be transmitted. So in our letter example, our letter left us as an envelope. It went to the post box and it was put in a bag, right? It was put in a bag with other letters. It made it to the sorting facility. It was put in a box. And those boxes were put in a pallet. And then they were transported, on different medias, either air, road, or rail. And then when they got to the destination, the pallet gets opened, and then from the pallet to the box, from the box to the bag, and from the bag to the post office who's going on a bicycle. I know nowadays they've got motorcycles, but yeah, once upon a time, they were riding bicycles. So he rides the bicycles, delivers the letter to your house. This process is known as decapsulation. And this process is known as encapsulation. So basically, it's a reverse of the other as the data is flowing through the different layers of the OSI. So so okay, so what is contained in the header? Now this is very important for us to understand. And by now you probably have realized that I like teaching by giving examples on things that we deal with on a day-to-day basis that make us understand. So I come to you, you go online, you buy something from Amazon. So they put it in a box, and on top of the box, they're going to put a label. Right. So you got a label on the box. Now, the label is not the contents. The label is just a sticker on top of the box that helps the box make it to your house. And I want you to consider the label as the IP header if we were looking at an IP packet that is traversing the network. So what is it going to contain? So your label is going to contain the address of who is sending the package. And why do you need that address? In the event that the packet does not make it to the destination, they can send it back to the source because they've got the source address. And then the label then contains the destination address. Right, this is your home address. You are the one who's receiving the packet. So there is the destination address. And then contained in here are barcodes. Right, and these are the barcodes that get scanned during the delivery process. right? So most of us get notification that your packet has left Sydney. You're now told it has arrived in Perth. You're now told it has gone out for delivery. And what is allowing that tracking to take place is the ability to scan this barcode, which then gives them the information that they're basically looking for. Now, in the IP world, we have an IP header, and that IP header is made out of these components that you can see. And I'm just going to touch on a few. Later on in the course, we're basically going to cover, the different aspects of the IP header and what is involved. And the first one that I want to look at is TTL. TTL is known as time to live. And this is a value or number that gets decremented as packets go through different hops on the network. So if you had a router 1, router 2, router 3, as a packet goes from one router to another, the value of the TTL gets decremented by 1. It goes to another, gets decremented by 1. And it goes to another, gets decremented. The reason why that decrement happens is to avoid something known as loops on your network. So the TTL is that value, and you specify whether that value is going to be 255, I think that's the default, or 64. And then what it basically means is that you can't go beyond 64 hops, because you won't have, when the number gets to 0, the packet gets dropped because it has done its hops that it has to traverse through that particular network. The second one is the source and destination address. And these are basically straightforward. Where is the packet going? Where is it coming from? That's what this basically deals with. And then you got the checksum, says what it is. It basically deals with verifying that the data has made it. There is an entire chapter dedicated to just understanding, these headers. And you will encounter these headers both on you'll encounter these headers both on TCP and IP. Okay. So the TCP header is made out of the source port, the source destination, right? It's made out of the source port, the destination port. We've got the sequence number, and the sequence number is basically used for tracking the sequence of the acknowledgement of TCP as communication happens between source and destination. So with the sequence number, it basically says, I've sent you 3 packets. So I'm expecting you to acknowledge, and that acknowledgement should be saying packet number 4, right? If I get a different number of value like 6, it means somewhere along the lines, or if you give me a value of 2, it means somewhere along the lines the data did not make it to the destination. And you got the acknowledgement number. And we spoke about the windowing. This is the part of the header that basically carries that windowing information. And as you can notice, the TCP header contains quite a lot compared to UDP. So UDP is known as a light protocol. It doesn't have much overhead. And there are applications that basically need that light protocol and utilize that. Things like video and some audio don't need the overhead, and thus the traffic is then able to flow through the network without too many issues. So that basically kind of gives us a nutshell of how the OSI layer basically interacts and touches us, on a day-to-day basis on the things that we deal with, and some of the concepts that are going to be important for you to understand in order to as you basically go through. And in wrapping off our lesson for today, we're basically going to close off by looking at some of the common ports that you're going to encounter. And these include, protocols such as FTP. So what these ports basically do is they are the ones that are used by these protocols to identify themselves as they traverse through the network. So they've got common port numbers, and below are some of the common ports that you're going to encounter and their numbers that are associated with those particular ports. And FTP is port 21, Telnet port 23, HTTP is port 80, DNS port 53, TFTP port 69, and POP3 is on port 110. Now, you don't have to master all of them, but you must know these ones, right? There's a huge number of ports. You can't master all of them, but there are some common ones that you're expected to know. Things like HTTPS, which runs on port 443. It is also imperative for you to understand whether a port is a UDP or TCP, because they're going to behave differently. And this becomes important when you're dealing with firewalls, because you're going to filter traffic, or when you're dealing with access lists, you're going to filter or permit traffic based on source and destination ports. And if you don't have an understanding of the actual port numbers, then it's going to be a bit difficult for you to then be able to filter the traffic that is basically flowing through. So it is important for you to have a full understanding of the protocols and the port numbers that they use as you go through this particular course. So that basically brings us to the end of our first lesson. And like I said, it will be good, if you can join live. I will make sure that I create the invitations. So if you go onto our YouTube page, if you've made it this far, you're going to find the different thumbnails for our live sessions, so you can then be able to join on that aspect. I'm also going to put a link to our Facebook page. This is where I'm going to probably put updates so that those that want to join in are able to join in. If you're going to watch this after the live recording, once again, don't hesitate to get in touch if you've got any questions. My email address is tinei@thenetworkhustle.com. I will be able to answer the questions in the upcoming sessions. And once again, thank you for taking your time and being with me. And I look forward to covering other aspects of this particular course and to get your feedback. So thank you for watching, and I'll see you in the next one.